Let us look at proposition number 2 of works of Archimedes, specifically from on conoids and spheroids. The proposition says if A1, A2, A3, An be any number of areas such that to each of the equal lines there be applied a rectangle exceeding by a square figure. So that would be this. Area 1 is equal to a straight line to which a rectangle is applied of height x and exceeding by a square. So to look at it graphically, we have a rectangle AX and to which a square has been added. So x square has been added. So we have AX plus x square. Similarly, we have this and this and so on. So basically, the terminology goes like this. A1 is a rectangle of height x applied to a line A, but overlapping it so that the base extends a distance x beyond A. These are the areas which are named as A1, A2, A3. Then what the proposition is saying is that n times An is to the sum of all the areas is less than a plus nx is to a by 2 plus nx by 3. And n times an is to the sum of all the areas except the last area is greater than a plus nx is to a by 2 plus nx by 3. Okay, let's take it one by one. By lemma 1, n times anx is less than 2 times ax plus a times 2x plus a times 3x plus a times nx. That is the sum of the rectangles, green rectangles. And by lemma 2.1, we have n times nx square is less than 3 times x square plus 2x square plus 3x square plus nx square. So which can be written as n times nx square by 3 is less than the sum of all the squares. Now let's add these two, get the complete rectangles. So we have an square x by 2 plus n times nx square by 3 is less than the sum of the right hand side, ax plus x square plus 2ax plus 2x square plus 3ax plus 3x square and so on till anx plus nx square. And these sums on the right hand side are nothing but the sum of the areas. So we have an square x plus n times nx square by 3 is less than a1 plus a2 plus an. So which means n times an is to a1 plus a2 plus a3 plus an is less than n times an is anx plus nx square is to an square x by 2 plus n times nx square by 3. Now here what we do is we take out n square x from both the terms here and take it out so that we have n square x times a by 2 plus nx by 3. Similarly here we have n common and x common. So we take 1 n and x out so that we have n square x times a plus nx. Now here both the antecedent and the consequent, they both have n square x, which means we can cancel them out. so that we end up with n times an is to the sum of all the areas is less than a plus nx is to a by 2 plus nx by 3. The same procedure we follow for the second case. By lemma 1, n times anx is greater than 2 times ax plus 2ax plus 3ax plus dot 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 plus a times n minus 1 x, which can be written as an square x by 2 is greater than ax plus 2ax plus 3ax plus dot 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 plus a times n minus 1 times x. And by lemma 2.1, we have n times nx square is greater than 3 times the sum of all the squares except the nth square. Adding up both these, we have an square x by 2 plus n times nx square by 3 is greater than ax plus x square plus 2ax plus 2x square plus dot 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 a times n minus 1 x plus n minus 1 x square. Now, this is nothing but the sum of the areas except the last one. So we have an square x by 2 plus n times nx square by 3 is greater than the sum of all the areas except the last one. So we have n times an is to the sum of all the areas except the last one is greater than n times anx plus nx square is to an square x by 2 plus n times nx square by 3. Here again, commonalities we take out. So here we have nx common. So when we take it out, it becomes n square x times a plus nx is to, here again, n square x and n square x is common. So we take it out and we get n square x times a by 2 plus nx by 3, which means they get cancelled out. So we have n times an is to the sum of all the areas except the last one is greater than a plus nx is to a by 2 plus nx by 3. That is proposition number 2 of works of Archimedes, specifically from on conoids and spheroids. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now.